Here we are, video 2 of section 2.5, and we are continuing with the examples. Realize we're ready for number 9, and there's quite a set of directions here. Basically, we're asking, can it be extended to be continuous at the point x equals 0, which basically means, is there a hole in the graph right at x equals 0? And if so, we're going to approximate, round it to 4 decimal places, the particular value. Now realize what this is going to basically mean is that we're going to have to go to our graphing calculator. But realize that if we can't continuously graph everything, or if we can't continue a function at a certain point, then we might be able to do it one side at a time, in which case we would try to find the one-sided limits. And then there are some times when we just can't extend either way. This is particularly true if we're doing something like going to infinity. That's the big time when that actually occurs. So what's going to happen, I need to get my calculator up here. What we're going to do is we're going to first of all try and graph this particular graph. So let's go to my window first, and I'm going to set it to the default window, so -10, 10, 1, and -10, 10, and 1. And then I'm going to clear out what I had before and put in what is shown there. So it's parentheses 1 plus 2x, and then we're going to raise this to the power of 1 divided by x. And that's all we need. And so we're ready to graph this and see what we get. Now, to me, what I see is it certainly looks like it just stops right there. But at the same time, it doesn't look like it's actually an asymptote here either. So I do need to do a little bit of investigation here to see, you know what, is this just not a good window? So I'm going to spread this out a little bit. And since I'm really interested in only at x equals 0, I'm going to change my x min and x max. Let's change it to a -2 and a +2, and graph it again and see what we get there. Ooh, now I look at this and see, okay, I see that it does continue over here. So this appears like, you know, this is a constant or continuous function, but I know for a fact that it can't be at x equals 0 because then the exponent would be undefined. So I know that there's a hole here, and that's why graphing calculators aren't the all beat all, you know, end all to beat all, because it doesn't show holes very well. Okay, but I want to see a little bit more up here. So let me change the window yet again. I'm going to make my y min be 0, because I know for a fact that everything's occurring up above. And let's make the y max be 20, and let's let the scale, the y scale, be 5. I don't know why that didn't change to 1, but oh well. Okay, there, it's pretty obvious. Now, if I remember, y scale was 5. So I've got a mark here and a mark here. It, you know, maybe 7, 7.5, somewhere there. But we need to get a fairly accurate value here. So what I'm going to do is I'm going to use the calculate problem, or part function to the calculator. So do second and then calculate, which is this button right here. And then I want an actual value. I could try and intersect, but it's just going to give me an error. So I'm going to give a value, or I want to find a value, and I want it really close to 0. So I'm going to put in -0.00001 and see what I get. Hit enter, and it says 7.38 7.3892. 7.3892, because that's to 4 decimal places as being asked. So that's when I'm coming in from the left. 7.3892. Okay, now I'm going to do another calculate. Just go slightly to the right of it. I want to find my value, and I'm going to put in a positive 0.0001. And let's enter to find the value there. 7.3876. Okay, so I've got 7.3876, and I can't remember what the other value was. So I've got 7.3876. Hurry and do the calculation again on the negative side. Negative 0.12341. And it's 7.3892. So since I've got two values that are really close to x, I'm going to just take the average. Maybe it's not a good idea, but you know what? This is my class. That's how I'm going to do this. So I guess that means you're allowed to do that as well. So the average between 7.3876 and 7.3892 would be 7.3884. So that will be my approximation, 7.3884. Example number 10. Find all numbers a and b or k such that f is continuous at every point. And basically they're going to give a piecewise function, but basically we just need to make sure right at those break-off points, or right at those breaking points, we need to have the exact same values. So it appears in number 10 that -9, when x equals -9, that's the breaking point. So right at -9 on the top, it's going to look like this. I'm going to actually find that value. 4 times -9 plus 3 is -36 plus 3, which equals -33. Now that's what the top function is. At the bottom function would be k times -9 plus 6. Or in other words, -9k plus 6, and that's as far as we can go. But in order for this to be continuous at every point, that means this right here has to end up being in the exact same spot as this right here. Or in other words, those two must be equal to each other. So -9k plus 6 equals -33. Then it becomes a simple algebra problem. Subtract 6 and divide by -9 so that k equals 13/3. And we have answered the question. We found the numbers k so that it's continuous everywhere, even at -9. Okay, the final group here says provide an appropriate response. Well, we begin with the intermediate value theorem. Intermediate value theorem basically says if we take a function and we find the value at some point, and then we find a value at some other point, and they are different, then we can guarantee that somewhere in between those x values there are values somewhere between the respective solutions for each one of those. Now specifically number 11 says use the intermediate value theorem to prove that x times the quantity x minus 3 quantity squared equals 3 has a solution somewhere between 2 and 4. And remember that in order for it to have a solution, we're looking at where does the function actually, or where does x times x minus 3 quantity squared equal 3? Or we can move that 3 to the other side and ask where does it equal 0? And that's the way I prefer to work with. So let's do that first. We have x times x minus 3, quantity squared, equals 3. And then we can we can subtract 3 from both sides. And this is what our function is going to be, f of x. F of x becomes this, and we're looking for the zeros. So we're told somewhere that it has a solution somewhere between 2 and 4. So I'm going to find f of 2. F of 2 would equal 2 times 2 minus 3, quantity squared, minus 3, equals 2 times 1 minus 3, which equals 2 minus 3, which equals negative 1. And we're also told somewhere between f of 4, or 4 also. So that would be 4 times 4 minus 3, quantity squared, minus 3. That's 4 times 1 minus 3 equals 4 minus 3, or positive 1. Now, basically, since f of 2 is negative and f of 4 is positive, then there is a solution. Between 2 and 4. Because if one's positive and one's negative, and it is a continuous function, oh, very important part, it does have to be a continuous function. So, and if we look, this is continuous everywhere. And so, yeah, big thing, it has to be continuous. Sorry about that. First mistake of the year, but that's okay. And so, anyway, what we get is, since one is negative and one is positive, that means at some point it had to cross that x-axis, which is a solution to this particular equation. Example number 12. A function is continuous on negative 4 to negative 1. It is known to be positive at x equals negative 4 and negative at x equals negative 1. What, if anything, does this indicate about the equation f of x equals 0? And we want to illustrate with a sketch. Okay, well, basically what we're talking about is at negative 4, it's positive. At negative 1, it's negative. So if this is negative 4 and this is negative 1, we've got this. It's continuous, so it can do whatever we want it to do. And it is a function, so it doesn't have to abide by the vertical line test, but I sort of messed up. But realize it can do anything at once as long as it keeps on going and never goes backwards. But this is what we get. And then the question becomes, what does this prove? Well, in other words, what does it indicate about the equation f of x equals 0? Well, right there means it happens, so that means it has a solution on the interval between negative 4 and negative 1. And then finally,